31. So this is a square root. Or is that cube root? Very poorly copied. Cube root. So our cube root parent function, -8, -1, 0, 1, 8, -2, -1, 0, 1, 2. So that's our parent function. Hopefully you have that memorized from our last test, last project. Our translations, -2 inside is what? Right 2. And -3 on the outside, down 3. So I'll move all these points right 2 and down 3. You can do it in your table too, or you can just take each point and go right 2, down 3. If you can count. Right 2, down 3. Right 2, down 3. But to help you know what points I'm graphing, I'll go ahead and do the table as well. Right 2, I add 2 to all my x values. So -8 plus 2, plus 2, plus 2, plus 2. And then down 3, I'm minusing 3 to all my y values. Minusing 3, so -2, minus. If you're graphing it in the calculator, your steps to get your table is menu, split screen, table split screen, I think is what it's called. And then it'll give you a table. Most of them will be decimals, but you can scroll and get the nice ones, nice numbers. Control T? Oh, yeah. Control T2.
Do you have any?
And remember, domain and range for cubic is always name infinity to positive infinity. I know I'm doing odds, but number 3 is another cubic, so I want to do square root instead. So I'm going to do 32. So you get some of each. Slow me down if I go too quick or if you have questions. The parent function is your square root. I am going a little fast so that you can have time to ask me questions at the end on all the other ones, but I don't do. -3 inside the radical is right 3. Right 3. So I'm adding 3 to all my x values. Or I'm just moving all these points right 3. 1, 2, 3. That one's off the graph. I'm adding 3 to all my x values. 3, 4, 7, 12. And then once you get your x values, you can just plug them in. 4 minus 3 is 1, square root of 1 is 1. 7 minus 3 is 4, square root of 4 is 2. But they should stay the same. Domain, start on the left, work your way to the right. Our first x value of my red graph, 3. And you put a bracket, because there's a point there. And it goes on forever to the right, infinity. My first y value, start at the bottom, go to the top. 0, 2, infinity. Yeah. Yes.
If
All right, so solving equations, when you have a square root, cube root, any of those, when you solve those equations, the first thing you want to do is isolate your radical. That's supposed to be an L. Isolate the radical. If it's square root or cube root, either one. And then you raise it to the proper power. The proper power for square root is squared. Cube root is cubed. You'll see that in a second. Solve like normal. Check your answers. Okay, so get the square root by itself or the radical by itself. So we have to get rid of the 2. Divide by 2. Oh, that's even. Well, guess we're doing it. All right, raise to the proper power. This is the square root. To get rid of square root, you square both sides. Because the square root and the square cancel. And then the square root, and not square root, 3 squared is 9. So x equals 10. To check your answer, what you have to do, you show me 2 steps. You plug it back into the original equation, and the left side equals the right side. So I'm going to plug 10 into the original equation. And this left side equals the right side. So you can put all that in the calculator. 2 square root of 10 minus 1. Or do it in your head. 10 minus 1 is 9. Square root of 9 is 3. 2 times 3 is 6. So your answer is right.
So, how'd you get credit on the test?
All right. 35, because that's odd. Isolate your square root. Then what do I raise both sides to? Square. Get rid of square root. You square both sides. So the square root and the square cancel. Negative 7 squared. Positive 49. Negative, negative, positive. And then minus over 5. Check your answer. Go back and plug in your answer. Make sure the left side equals the right side. (44 plus 5 is 49. Square root of 49 is 7. 7 plus 10 is 17. 17 equals 3. False. So 44 does not work in your equation, which is why you have to check your answer. So your answer is no solution. You should have been able to see it was no solution, though. Because up here in black, the square root of x plus 5 equals negative 7. it can't equal a negative. Square root can't equal a negative number. Questions? Rational exponents. With the equations, just write them as a radical and then do the same steps. So 1/2 as an exponent is just square root. 2 is your index. You don't have to write 2. That's just an assumed square root sign. And everything's being raised to the first power. The square root's already by itself, so raise both sides to the squared, because square root and square cancel. So 4x plus 5 equals 9. Solve it like a normal equation. X equals 4. X equals 1.
Something like that, we can just square it and then we should
Because 1/2 times 2 cancels out. And then we're plugging in 1 to my equation to make sure it's equal. 4 times 1 plus 5. I'd put that all in a calculator. It's true. 4 times 1 is 4, plus 5 is 9. The square root of 9 is 3. There you go.
That's like half, not square root.
1/2 is the square root. Oh, here? Yeah. Yeah. Because this is, remember from yesterday and, I don't know, last week sometime. The bottom is your root. So if it was x to the 1/3, that's the cube root of x. X to the 2/3 is, the bottom is your radical, the cube root of x squared. So the bottom is your radical, the top is your power. And that's basically what the whole front page deals with, which is why I think the front page is the hardest page of this whole thing. If you have two radicals, you're still doing the same thing, but you can't isolate your radical. You can't get it by itself. So you just go ahead, get one on each side, which I'm not going to give you anything harder than that, and raise it to the proper power. How do I get rid of cube root? Cube both sides. So to get rid of square root, you square both sides. To get rid of cube root, you cube both sides. Because the cube root and the cube cancel. Anything in the cube root comes out. But on the left, the 2 isn't in the cube root. So the 2 still has to be cubed. So it's 8x. And then we solve it. Minus over 2x. Divide over by 6. Check your answer. Plug it back in. 2 cube root of 3 equals 2 cube root of 3 equals, I have no idea. I'm gonna put in calculator. So the left side, 2 cube root 3, 2.88. Two cube root cube root 2 times 3. No. Two times 3 plus 18. So they both equal the same thing. 2.88, 2.88. You could simplify it like actually cube rooting it, but that's not the purpose of that question. All right. Still isolate the radical. So this on 41 it is, but on 40 I'd have to add over 5. Square both sides. Square root and square cancel. So anything in the square root comes out. But on the right, it's not in a square root. So you just have to square that binomial. And remember, when you square a binomial, you times it by itself. So when you square a binomial, you have to multiply it by itself, just like with imaginary numbers and square root numbers and everything like that. Then we'll have to distribute. X squared plus 4x plus x plus 16. Eight x plus 16. So you have to get everything on the side with the x squared, because you don't want to move everything on this to the other side. You want to keep your x squared positive. That's what I'm trying to say. Try to keep your x squared positive, because otherwise you're dealing with negatives, and it's just going to be more complicated. So I'm going to move everything to the side with x squared. I'm going to do them one step just to save me time. So 0. All right, let's see how many of you remember. We need to know what multiplies to 10 and adds to 7. What two numbers would multiply to 10 but add to 7?
5 and 2.
Nice. 5 and 2. 5 times 2 is 10. 5 plus 2 is 7. So when we're factoring this, and factoring is the opposite of distributing. So we're going to divide this trinomial into two binomials. So x times x gives you x squared. And then the 5 and the 2 will give us 10. And if we do the inside of our FOIL, 5 plus 2 will give our 7x.
What?
Okay. So we factored it. Now, if you are multiplying two things together and you get 0, what can you tell me about those two things? They have to be 0. At least one of them has to be 0, if not both. So that's why you set each parentheses equal to 0, because this is getting multiplied to this, and it equals 0. So I need one of these parentheses at least, if not both of these parentheses, to equal 0. Because if I plug -5 in here, then this equals 0, and 0 times anything is 0. So that's why you set both factors, both parentheses, equal to 0, and solve. So there's two solutions. And then we have to check both of them to see if both of them work or if none of them work. Or if one of them works. Lots of different options. Back up to the top. Plug in -5. So when I plug in -5, I get the left side is 1 and the right side is -1. So that one doesn't work. -5 is not one of my solutions. When I plug in -2, do the easy side. 2 equals 6 minus 2 is 4, square root of 4, 2. So 2 equals 2. So that side does work. So my answer for this whole question is x equals -2. So why this is bonus is because I don't know what happened last year or 2 years ago when COVID was like starting. I don't know if you learned factoring or not. Usually this would just be a regular question on the test. Plus it was absent, so we didn't get to do that.
We had.
So when you're graphing these to solve it, you're going to graph the left side of your equation, and then you're going to graph the right side of your equation and find where they intersect. So first I'm going to graph the left side of my equation, y equals the square root of x plus 6. And you should know what that looks like. That's just square root moved left 6. Nice. So instead of 0, 0, -6, 0.
Okay, and the square root, you go up 1 the first time, and then over 3 for the next one, right?
Uh-huh. So those are the points we're moving left 6. Well, in this one, it's until you find the intersection. I want to see the shape of it. So in the square root, you need to make sure you show the end point or the start point. Left 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I think that's right. I'll draw my table so that you know. Write my table, I mean. So your parent function, 0, 1, 4, 9, 0, 1, 2, 3. I'm moving that left 6. So I'm moving my x values 6. So -6. 0, 1, 2, 3. -6. -5. -6. -2. Okay, good. So that's the left side of my equation. Then the right side of my equation is x plus 4. Which is what kind of graph? Linear. Linear. Moved up 4. So 0, 4. If I plugged in 1, I'd get 5. 2, I'd get 6. And you have a graphing calculator, so if you didn't know or if you forgot, you can just graph it on that and get all these nice points. Say it again. It intersects at x equals -2, so that would be your solution, which is what we found up here too. X equals -2. So the x value where they intersect is the answer to your equation. That also works for all of these. So if you want to check your answers to see where they intersect, you could. Do you want to do that for one of these? Or just keep going? But if you graph the left side of any equation and the right side of any equation, where they intersect is always your answer. So with imaginary, remember, imaginary is the square root of -1.
What?
All right. So square root of -1 is imaginary. Then we have to know I squared. It's the one used the most often. -1. I cubed. -I. We don't use a lot, but you'll see it. And then I to the 4th is the best one because it's 1.
Oh, we have to have that memorized?
Mm-hmm.
Great. But we only have to go I to the 4th power memorized,
Yeah.
right?
That's as far as you have to go.
We're not going to have to know I to the 6th.
You will have to know I to the other powers, but it repeats. After 4, it just goes back to I. Yeah.
What?
After I to the 5th, we're gonna get there. We did these. Yeah.
I to the power of I would be -1. Not to the power of 6.
-1. Well, I'll get there. I'll show you. All right. 45. This is also division. So remember when you're dividing radicals, you can do the radical of the top and the radical of the bottom. I'll make that -49. Do you know the square root of 49? 7. So here, I guess I'll just -1 times 7 times 7. If you were to spell it out, you don't have to spell it out. You know the square root of 49 is 7. But that negative makes it 7i. Every 2, 1 comes out. And then the square root of 4, 2. What about 46? It's negative, so we know it's imaginary. 18. We don't know the square root of 18. If you put in a calculator, it'll give you a decimal. We don't want any decimals. 3 and 6. You can do 9 and 2. So no matter which way you break it up, you're going to have 2 3s and a 2. So if you use 3 and 6 or 9 and 2, you're going to get to 2 times 3 times 3. Since this is square root, every 2, 1 comes out. If it's cube root, every 3, 1 comes out. So the -1, square root of -1, is what? I. So that's where I comes from, right here. That's I.
Does that not stay in?
No, it comes out of the radical. You should never have an I under the radical because that'd be a square root of a square root. And we're not doing that. I've never even seen that. 2 doesn't have a pair, so it stays in. And then 3 times 3 is 9, and the square root of 9 is 3. So that's why 1 comes out. That's your answer. Back to odds. 47. Are we adding, subtracting, or multiplying these parentheses? Adding. Make sure you look at that. People miss this question because they like FOIL because they're not looking at the middle sign. So we're adding. Real go together, imaginary go together. So 6 plus 3, -2i plus 14i. What?
That's 12.
Uh-huh. I'm dysgraphic. I reverse numbers in my head.
Oh, that's the whole end, so like you get.
And you treat like these aren't like terms because like I is like a variable. You can't put those together.
Questions that easy going to be on the test?
There's one like this.
Only one though?
Yeah. This is a lot of information.
You should have like half the test like to where at least we're guaranteed a 50 like middle school time. I do miss those days where I could bomb it and still get a 50.
We're gonna simplify this, and then do that. So square root of -16. 4i. Do you want me to break that down, or are we just good with 4i? Are you good with 4i? Square root of 16 is 4. Square root of negative is I. Or do you want to see it all worked out?
No, I understand that.
Okay. Anybody else want to see that worked out? No, we're just happy with 4i. Sold. What about square root of negative 81? 9i. Are we adding, subtracting, or multiplying? Subtracting. We're subtracting. So make sure you change the signs of your second parentheses. Minus 9i plus 2. And then combine like terms. Make sure you put the real number before the imaginary, because this will be on your test too, right? In standard form. Real number before imaginary. 14 plus 2. Negative 4i minus 9i. Sounds good.
We follow formulas from the table. Big difference. So you do addition and subtraction.
So 51, add, subtract, or multiply. Multiply. So we're going to distribute. 4 times 2. 8. 4 times negative 6i. 5, negative 5i times 2. Wait, why did I square that? That's not squared. Sorry. Negative 5 times 2 is negative 10i. And negative 5i times negative 6i is positive 6. Negative 5i times negative 6i is positive 30i squared. Whoops. Combine like terms. Never leave I with an exponent greater than 1. Because I squared, we know, is negative 1. So that's just minus 30. Because I squared is negative 1. So 30 times negative 1 is negative 30. And then the real comes first. So put 8 minus 30. Then negative 30. All right, 53. Binomial being squared. Multiply it by itself. And do the same thing we just did. Same steps. Combine like terms. 56. Sweet. 49. I squared is negative 1. So that's minus 49. And if I were you, I'd probably skip this step, but I want to show all the steps so that you know where everything's coming from. Can I take that as fact?
Yeah, I
Great. Okay. I to the fourth is the nicest one because it equals 1. So if it is a multiple of 4, 8, I to the 12th, I to the 16th, I to the 20th, I to the 24th, it's going to equal 1. Easiest way to do it. If it's a bigger number, my list obviously doesn't go to 38 or 35. We need to know how many times 4 goes into it and what's left over. So in 17, 4 goes into 17 4 times with 1 left over. So 4 goes into 17 4 times with 1 left over. So that means I can write I to the 17th as I to the 4th 4 times with 1 left over. I to the 4th is 1. So this is just saying 1 times 1 times 1 times 1 times I. So it's I. So if you can do your division of 4 and find your remainder, that's what's left over.
What? That, what?
So multiples of 4 is equal to 1. So let's see if,
Okay, but what?
why?
You just pulled 4 out of nowhere and decided
Because 4 is the nice exponent because it equals 1. So here, I to the 16th is a multiple of 4.
So then it automatically equals just I.
So I is the only thing left over, so it's I.
I'm failing this part for sure.
So I to the 35. What is the closest multiple
I don't get that.
of?
I don't understand 55 at all. But
Well, we're doing 57. It's the same thing. And I'll try to go slower. I'll go back to 54. I did 2 different ways, so that might have been confusing. 35. How many times can 4 go into 35? 8. 8 times 4 is 32. Okay. How many is left over? 3. So I to the 32, since it's a multiple of 4, is 1. This is just 1. Oops, no equals. And then I cubed is one of the ones I want you to memorize. Is negative I. So this would just equal negative I. On 59, to rationalize, you multiply the top and the bottom by the complex conjugate. So remember, the complex conjugate is the opposite sign of the imaginary. So on the bottom. All right, so the opposite sign of the imaginary part. So what is the complex conjugate of 4 plus 7i? 4 minus 7. You do both that to the top and to the bottom. And the whole purpose of that is to get the imaginary out of the denominator. So by multiplying by the complex conjugate, that gives you back to the real world numbers. Gets you away from I on the bottom. I see a lot of people do it in 2 parts. I like that. So we'll do the top first. And then the bottom. 14 minus 28. 14, 28, I plus 28, I minus 49, I squared. Just by distributing. With the complex conjugate, your middle numbers should always cancel out. I squared, -1. So that's just 16 plus 49, 65. So that's the bottom. So we have 8 minus 14i on top and 65 on bottom.